All right, so yesterday we were kind of not stuck, we were working on this problem, but we did an example problem. And the example problem was, somebody's going to help me out here? 2x minus 3, like that, to the power of 5. So we know this is what? This is that's row number 5. So we started out by doing this. 1, open parentheses, plus, and then I put the number 5. And then I open up the group of, so here we go, plus, then we have a 10, open parentheses, plus another 10. So this is how you do it whenever you get one of these problems. 5, and then finally a 1. Okay, see if we can put it here. So first one we're going to put what? 2x all the way across, right? 2x all the way across. So make sure some of you guys have your graphing calculators ready to go, because I'm going to depend on you to do some computation with the calculator. The next thing we're going to put over here is we're going to put a -3 in the other slot. Like this. Okay, like that. Now, understand, if that's to the power of 5, then I have to do it in descending order. That's going to be a 5, that's going to be a 4, that's going to be a 3, that's going to be a 2, that's going to be a 1, that's going to be a 0. The other ones, what are we going to do? We're going to ascend. We're going to start from 0 and work our way up to what? What do you guys notice? The pattern there. We're going from 0, we're working our way up to 5. So this is where I need you guys' help, okay? Now, 2 to the power of 5 is 32. X to the power of 5 is x to the power of 5. But anything to the power of 0 just becomes a 1. So my first term is what? 32x to the power of 5, and I'm done. Okay? Over here, we have a plus. Okay? But we have a what? A -3. So what numbers are being multiplied? We have a 5. What is 2 to the power of 4? That's a 16, and it's being multiplied by what number? A -3. So here's where I need your help. Can you guys do 5 times 16, which is 80? And 80 times -3, I should get -240. Is that correct? Anybody help checking me here? Good? Okay. Now, what's that? That's x to the power of what number? X to the power of 4. Okay? Now, we go over here. We have a negative times a negative, which is a positive. So what are the coefficients? 2 times 2 to the power of 3, which is 8, times 3 squared, which is 9. 8 times 9 is 72. 72 times 10 is plus 720 x to the power of 3. We keep working our way down. We have what? We have a plus 10. 2 squared is what? 2 squared is 4. A negative times a negative times a negative stays a negative. That's -20. That's -27. So here's where I need help. -27 times 10 is -270. But what's -270 times 4? Help me out. -270 times 4. Nobody's helping me. Are you guys really going to make... -1080? That, okay, so this is where this, all right, and that's x to the power of 2. Over here, we've got a 5 times a 2. Now, -3 to the power of 4 is 81. So we got to do 5 times 2 times 81. All right, so we got positive 810, and that's going to be in x. Last but not least, we have minus, because that's going to be, there's 5 negatives, -3 to the power of 5, I think, is that -243? 3 to the power of 5? Yeah, so put minus 243. That is my bad jamma right there answer. That thing is... Now, if you have other variables, then you have to raise those variables to a certain power. But that's just an example of if you have, say, a 2 and a -3, how you would plug it in and how you would work it out. So that would be my final. Notice the pattern. Positive, negative, positive, negative, positive, negative. If everything's plus, it's easy, right? Because everything would just be plus. All right, if you're wondering why I'm going so fast, we're going to skip over number 11, and we're going to go straight to removable discontinuity, okay? So you have to know how to do removable discontinuity. So does anybody know what the numerator factors to? Okay, difference of squares. So that becomes x plus 2 and x minus 2. Now this factors to x minus 3 and x minus 2 because negative 3 plus negative 2 is a negative 5, and negative 3 times a negative 2 is a positive 6. Now, removable discontinuity, what has to happen? Something needs to be removed. So what was removed? The x minus 2's were removed. And so what does x equal and that removable discontinuity? X equals 2. So what do we call this number at x equals 3? What do we call that? That's going to be our vertical asymptote. At a negative 2, what do we call that? We call that a 0. That's a 0 of the function. Okay? So here's what I'm going to do, guys. I'm going to continue this video, and I will just put it online for people who want to watch it. They can. Our class was shortened today. So you have to know 3 things. Vertical asymptotes, removable discontinuity, 0. By the way, do you guys anybody know what the horizontal asymptote would be on this one? We can also learn that. Y equals something. Nope. Nope. 1. Because see these powers are they're the same. And if they're the same, then it's just whatever this coefficient is divided by this coefficient. Okay? If this was a 3, then it would be none. If this was a 3, then it would be y equals 0. Okay, but I'll be going over. So like what questions am I going to go over still? I'll go over this, like this one right here. We'll go over slant asymptotes. So I'll kind of go over those. There's not a whole bunch left to do, but I'll go ahead and finish that later. All right, so apparently what I said was wrong. We'll be able to keep going because I can't read my own handwriting. Yay. Okay, so my apologies. Let's just go up here and calm down. All right, just calm down, dude. Seriously, just calm down. All right, so we've already factored this. All right, that was x plus 2 and x minus 2. Let's keep calm and move on. X minus 3, x minus 2. What do we notice about these? We have removable discontinuity, and we found the removable discontinuity to be right here at x equals 2. I'll call that the RD at x equals 2. This, what did we call that? That's a 0. And where was our 0 located? At x equals what? Thank you. Negative 2. X equals negative 2. All right. So what is that? What are we left with? We're left with what's called a vertical asymptote at x equals 3, because that would make that equal to a 0. So this one, we only have one vertical asymptote at x equals 3. All right. So here's what we have. We have a vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 1 because these powers are the same. We have a removable discontinuity at x equals 2, and we have a 0, like an x-intercept, at x equals negative 2. So these are all the concepts that you're going to need to know how to find in a rational function. Okay? So we'll do one more example of this after in this video, but that's what you need to be able to find. So let's take a look at this one. Number 14, it says, what is the horizontal asymptote of this function? So what's this power? A 1. What's this power? A 1. What do you notice? They're the same power. So this follows the rule. If these powers are the same, our horizontal asymptote is going to be at this coefficient over this coefficient. So what's going to be my horizontal asymptote in this particular one? 1 over 2. And that's our horizontal asymptote. Now, everybody, let's find the other pieces. I could use this exact same problem, and I could ask about something other than what? Other than a horizontal asymptote. What could I factor out of the denominator right here? What number? What number goes into both those? 2. So I could factor out a 2, and that would be what? X minus a 3. What number could you plug in there to make that equal to 0? Positive 3. So what does that mean? That means we have a vertical asymptote at x equals 3. So we have a vertical asymptote at x equals 3. Y equals 1/2. That was our horizontal asymptote. What number could you plug into the numerator to make that equal to 0? What number goes right there? I'll erase everything right there. What number could you plug in there to make the numerator equal to 0? 0. So what does that mean? That means we have a 0 at x equals 0, which means we have an x-intercept at 0. That's what that means. Okay? So these are the things you would need to be able to find. Okay, everybody, here's what I need you to do. Write down g of x. Okay? So put g of x right here. Write that down. And it says, what is the slant or oblique asymptote in the form of y equals mx plus b? If you get a problem like this, I want you guys to know exactly how to do it. Okay? So write down g of x equals this. Write it down. And then I'd like you, by the way, I'm only going to make you guys use synthetic division on your 6 weeks test. Okay? I will not make you do long division. I'll just do synthetic. All right? Just don't tell anybody. Nobody's going to watch this video anyways. Just kidding. I'm sure the online people are going to watch it. Just kidding. All right, there we go. So we're going to start out with what? X squared, then work our way down to x to the first and x to the 0. How many x squareds do I have, everyone? 3. How many x to the firsts? 8. How many x to the zeros? 6. If that says x plus 5, what number am I going to plug in? -5. Very good. And we just do what? We drop it down. Okay, so drop down a 3. -5 times 3 is -15. What do we have to do? Add them together. We get what? -7. -5 times -7 is 35. We add this together. We get 41. But here's what I want you to understand. When you are looking for a slant or oblique asymptote, this is your x to the power of 1. This is your x to the power of 0. This is your remainder. You don't have to worry about your remainder when you're trying to find a slanted asymptote. Does anybody remember the rule for slant asymptotes? This degree has to always be what? 1 degree higher, right? Or this degree has to be 1 degree less, or this one has to be 1 degree higher. Why are we allowed to use synthetic division? Because this is just x to the power of 1. So I will only use a quadratic divided by a linear to help you find your slant asymptote. You are going to have to find a slant asymptote, okay? So what do we have? We have 3x. What do we have? -7. Your slant asymptote is this right there in slope-intercept form. This is in y equals mx plus b form. So what would I want you guys to type in if I gave you, quote, a fill-in-the-blank one? I'd literally want you to type in y, then the equal sign, then a 3, then a lowercase x, then a -7 with no spaces. Just type it in. If I say type it in this form, I want you to type it in that form. Okay? All right. Last problem, everybody. Here we go. I want you guys to put f of x equals. All right, I want x squared plus 8x plus 16 over x squared minus x minus 20. Okay, that's what I want you guys to put into your journal, please. First thing we're going to do is we're going to factor. Give me two numbers that add up to 8, but multiply together to equal 16. Right? X plus 4 and x plus 4. 4 plus 4 is 8. 4 times 4 is 16. That one's an easy one. This is called a sum of squares. Not a difference of squares, a sum of squares. This one's a little bit trickier. We're looking for two numbers that add together to equal -1, but those same two numbers multiply together to equal a -20. What are those two numbers? -5 and a +4. -5 and a +4. So this is what? X minus 5 and x plus 4. So here's what we need to figure out, guys. We got a problem. We have something that happens right there. What is that? Removable discontinuity. Where is it at? It's at a what? -4. It's at -4. What number would you plug in there to make that equal to 0? 5, which means we have a vertical asymptote where? Vertical asymptote at x equals a 5. Wait a second. Can we have a 0? Can we have a 0 at -4 and have removable discontinuity at a -4? Can we have a 0 and removable discontinuity at the same time? No, there is going to be no 0. Okay? There will not be a 0. There will be a hole right there. And that's what I need you guys to understand. Even though you can plug in a -4, because we have removable discontinuity, these are the only two things that are happening right there. By the way, the horizontal asymptote would be y equals 1, once again, because these powers are the same, and that's a 1 right there, and that's a 1. All right, so study up. Hope you guys have a good day. Make sure you have all that stuff down, because that's what you're going to be tested on tomorrow. All right, so I just want to make sure you guys understand right here. If I use a -4 real quick, I want you to see how we have a removable discontinuity at -4. So I want to show you the graph at -4. It is undefined. So I just want to let you know.